Hello, and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy them. So check out Linode. With 200 gigabit private networking, scalable shared block storage, and a 40 gigabit public network, you've got everything you need to run a fast, reliable, and bulletproof data platform. If you need global distribution, they've got that covered too, with worldwide data centers, including new ones in Toronto and Mumbai. Go to dataengineeringpodcast.com/Linode today to get a $20 credit and launch a new server in under a minute. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, read the show notes, and get in touch. And don't forget to go to dataengineeringpodcast.com/chat to join the community and keep the conversation going. Your host is Tobias Macy, and today I'm interviewing George Perrin, author of the upcoming Manning book Spark in Action, 2nd edition, about the ways that Spark is used and how it fits into the data landscape. So Jean, could you start by introducing yourself?
Sure. Good evening, Tobias. And I've been working in data engineering and around software for like 25 years. And I would say I've been kind of constrained in what they now call, or what we now call, the small data space, like a relational database and the small data, for a long time. And I wanted to discover and be useful using more of these bigger data sets. And that's where I never found satisfaction with Hadoop. And when Spark started to be out and more popular, I said, well, maybe that's a time to actually skip, this step and go a little bit further. And that's where I am now. And I've been lucky enough to be able to implement Spark in a few projects, and it gave me the motivation to start this book. Went to Manning and they said, well, we love it, let's do a book together. And that's what we're doing.
And you said that you spent a good part of your career working in the small data space with relational databases. So do you remember how you first got involved in that area of data management?
Yeah, when I was living in France back in the good old days, when I was almost fresh out of college, I started working for a company which was doing some compilers for a 4GL language, and that was specifically working with Informix. And then they extended from Informix to Oracle, MySQL, SQL Server, and others. And back at that time, just a little bit fresh out of college and probably a little bit stupid, what I was saying is, I don't like databases. That's why I'm using Informix. And it really stuck with me for a long time. And I still love this relational database. But as data grows and data sets are growing, relational databases are not enough anymore. But that's how I started. And I still pretty fond of all those good old days. Not nostalgic, just, as it was.
And so can you give a bit of a background and explain what the Spark project is and some of the main use cases that people are leveraging it for?
So the way I see Spark, and I'm not the only one thinking, and actually I borrowed this definition from a friend of mine at IBM, Rob Thomas. And basically what Rob was saying is, Spark is an operating system. It's an analytics operating system. It's designed to handle pretty complex workloads of data processing in a distributed way. And when you look at the definition of what an operating system is and what it provides to your applications, I really think that that's what Spark is. It provides so many of these base layers and this base functionality that you would need in any kind of highly distributed application. And it provides you this abstraction layer as well. So when you're thinking data engineering and when you're thinking scale, that's where Spark has one very good role to play here.
And a lot of times in terms of the workflows that I see people referencing it for, I see some cases where it's analogous to a lot of the ETL frameworks that people might be familiar with as far as moving data from one place to another and performing some transformations on it. But I know that it also has things such as the machine learning layer and the SQL capabilities, and I believe that it has some graph analysis capabilities. So what are some of the main sort of tools and components components that people might use and take advantage of within that Spark framework or operating system, as you put it?
So you're totally right. Okay, there's a lot of people, and I've done quite a few projects in that space where it's basically creating a very high velocity data pipeline. And even if Spark, that's not the role where it was conceived, it excels in this world. And yeah, it can be a little bit of a competitor to some of the ETL. But also the fact that it brings this platform, it means that you can actually do this transformation at the same time. What I like about it is, okay, as you said, you've got Spark is they kind of divide Spark into 4 pillars, one being Spark SQL, the other one is Spark streaming, then ML and deep learning and GraphX, okay? So I think that one of the great things is by offering a very unified API on top of these features, you empower the developer and the development team in this very powerful features in a very abstract way. So when a lot of people compare Spark to Hadoop, and when you look at Hadoop, and especially the first version where Hadoop was only MapReduce, was only disk, well, you're creating a very niche set of capability, or a set of capabilities can actually be used by only niche players, niche developers, and you don't have that with Spark. Spark is actually offering all this APIs, basically the data frame API, to the developers so they can actually leverage making data ingestion, so basically taking data into Spark, applying some data quality rules, offering then using, for example, this data in a machine learning pipeline and exporting this data in another database or another kind of report in a very seamless way, in a programmatic but seamless way.
And who are sort of the main roles and types of users who might be taking advantage of Spark, both in terms of maybe doing some local development and also in the more production scale use cases?
So I see 2 big family of Spark users, one being the data engineers and the other family is the data scientists. And they have a bit of a different set of tools as well and different, of course, use cases. When I was just speaking about data pipelines, this is typically a use case for our data engineers. But Spark can be easily interfaced with products like Jupyter or Zeppelin, and by using these notebooks, this is really the tools of choice for data scientists, and they can leverage the power of a cluster very easily as they would be using their notebooks locally. And now you've got also companies like Databricks or IBM with Watson Data Studio, which offers more collaborative capabilities on top of it. That's really targeted to the data scientist. This is not the main scope of my book. I think that's a great data science, and data scientist is a great profession, and there's a lot of coverage on that. But I think that data engineers are a bit like left on the side of the road sometimes. So this is a population I was trying to address.
Yeah, it's a big part of why I've been running this podcast as well, to try and give more attention to all of the work and effort required to gather and collect and process the data that's necessary to power some of these data science and analytics applications.
Exactly, you're totally right. I mean, we sometimes forget that if you get garbage in, you get garbage out. Okay, and that's kind of the role of the data engineer, to make sure that we actually don't do this kind of bad paradigms. So, yep.
And are there any particular use cases that you think that Spark is uniquely positioned to be able to handle as compared to some of the other streaming frameworks or big data frameworks that might be available, such as the Flinks or Kafkas or Storms of the world?
So streaming is one of the components of Spark, and that's also why I'm going back to the definition of Spark as an operating system. Is it does not just do streaming, okay? But it also plays well with Kafka. I've got quite a few friends who and actually customers and partners using Kafka intensively with Spark, or if you're in the AWS world, Kinesis. So that's where Spark is nice as well. It plays well with others, and it also have its own streaming capabilities, which are more and more used by and now since version 2.2 and we're version 2.4 now are in production. So it's pretty mature as well on that part as well.
And in terms of the broader landscape of data tools and platforms, how do you see Spark fitting in? I know that you referenced Hadoop and HDFS, and there are some of the streaming frameworks that are available, and then there are people who will likely be landing some of that processed data into their data lakes or data warehouses, and you mentioned the ML capabilities. So I'm just wondering if you can give some perspective on how it fits in relation to some of those other tools and some of the other types of deployments and applications that it might be used for.
Hadoop has become at some point a synonym of big data, and I think that with Spark coming, it's almost like there's another kid in town, and that's actually empowering a new generation of big data developers. So and you can see it when you actually talk to users. You've got really two kind of in the data engineering space, or even in both spaces, but you see people that are now using Spark who are coming from the Hadoop world, and people that just a bit like me skipped Hadoop and went to Spark directly, and you see really two different usage in that part, where the people that came from Hadoop are already familiar with resource managers like Yarn or HDFS or Hive, and they think as Apache being a natural evolution of that, because it offers more algorithm, it offers ML, it offers SQL, and you've got the other population which is coming more from a data engineering background or like small data or RDBMS world, and discovering Spark and the familiarity of which you can do things the same way you would do it with a normal database. And of course, it's of course a lot more than a database where you can have all this processing being done as well with Spark, but it's a very natural transition as well. So what's interesting is to see this two population being kind of reconciled on big data through Spark.
And for somebody who's building an application on top of Spark or composing a data pipeline, what are some of the main design paradigms in terms of the way that the software is written and the interfaces that are available, both in terms of the way that the data is represented, but also in terms of some of the language runtimes that developers are able to target?
Surprisingly, you're not thinking big data when you use Spark, especially when you're at the level of designing and building your application. My experience was with many developers is that they understand the APIs, they learn the APIs. That's a kind of the key thing once you've learned the data frame API, and then deploy, because one of the big advantage of Spark is you can run everything on your laptop. Okay, you don't need virtual machines, you don't need a cluster. Sparks come out of the box with what they call the local mode, and you just spin off Spark like out of Eclipse or out of any environment very quickly, and you can run your application right away, and you can start developing in there. So, and then comes the deployment part, which is not that difficult. You've got to package things in a certain way, and of course, you've got to think about some of optimization. Okay, so if you're making massive joins of huge data sets, you know that you're going to create a lot of traffic. So it might be better to partition by the keys you're going to join on, right? But that's the same thing as you would do in a traditional RDBMS way. There's nothing new there. So it's in that way, it seems very natural and a very natural progression once more. Yeah.
And are there any major edge cases or shifts in design thinking or sort of deployment considerations when moving from that local mode to a more full-blown production scale infrastructure, particularly as you start to scale that deployment in terms of the number of nodes and the overall volume of data processed?
There is, but it's not a major shift in how you do it. Even when you drill down a bit the architecture of Spark, where you've got your master and you've got your workers that are actually doing the work, even deploying the application, you only deploy it once, and then Spark is actually distributing your code to the different workers, which makes it really really neat. And you don't have to really think too hard about what's going on. That was really surprising for me. But of course, to be completely honest, I've not manipulated petabytes of data, but on all the projects we've been doing, whether it was in healthcare or with log data, everything was pretty smooth when we went to production. It's not, sometimes when you're taking your application that works kind of in a almost lab way on your laptop, and you start wondering, oh, what can be wrong, you kind of freak out or about the deployment part. I never had that. I think I was more freaking out in the good old days of deploying things to Tomcat than deploying things on Spark.
And in terms of the way that you package and deploy the application, is there anything special in terms of how you need to create an artifact for that deployment? And does that change based on the language that you're doing the implementation is? Where if you're doing JVM based code such as Java or Scala, or if you're using something like PySpark?
Yeah, so that's a good point to add. Yeah, so to use Spark, you can use Spark in Java, Scala, Python, or R. And I think this is also a very smart way that they decided to cover these different languages, because you've got the languages which are more data science oriented, like typically R, and maybe data language that are more data engineering oriented, like I would say Java, but I don't want to create a big debate here. So that's also offering a wider range of potential users embracing Spark. When you're deploying your app, you can do it in several ways, depending on actually the goal of your application. One of the traditional way is to package your app as a single jar, and you just submit your jar. Okay, and then your jar could be written in Scala or in Java. It doesn't make any difference. When you're using, you can also use Spark via a shell, and then you would be in a very similar way as you would be using a notebook. Okay, you connect to Spark and you type your commands, and basically you get the result. In a very interactive way. The shell part is only available in Scala, Python, and R, because Java doesn't have this replay mechanism right now. So that's one way to access it. One other way is you can, as I said, you can submit your application, or you can connect directly to the cluster. So in some cases, for some project I did, we needed to have a permanent connection directly to Spark, basically because we wanted to have a session always open. We had big data sets that we wanted to have constantly being loaded and constantly being updated. So, and we opened just a kind of a REST endpoint in the application that would kind of status update of what the application would actually be doing directly. But it's not even a very complex use case as well. So this is all the kind of different scenarios you can use Spark, which is really depending on the workload you're planning on running on Spark. Once more, it's giving flexibility.
And what have you found to be some of the most useful strategies for improving the efficiency and performance of a processing pipeline? And I know that when I was looking through the book, you mentioned that one of the key aspects of the programming model of Spark is its laziness. So I'm curious if there are any special approaches for being able to employ that effectively.
So I love the laziness part, and I compared it quite a few times to teenagers, which I've got a lot in my family right now. And so the way I see it is, you can ask something, okay, like go clean your room, go put your laundry in the washer, and things like that. But as long as you're saying things in a kind of a normal way, they're not going to happen. But at some point, you've got to apply an action to have the things done. And that's exactly how Spark is working. You tell Spark to do a few things, basically data transformation. And at some point you say, hey, Spark, now it's time to get your shit together and work. And that's called an action. And basically, when you're building this recipe, it's being transformed into directed acyclic graph, which is basically a graph that never comes back to itself. And before it actually starts working, it's giving this to an optimizer called Catalyst within Spark, and basically Catalyst, like in a relational database, when you got your query plan, is going through it and saying, okay, I'm going to do that and that and that in this order, and then this is a result of this optimization, and then it can be, of course, that's going to make it even faster. So you've got first you've got Spark that works that uses memory in a smart way. So just by using memory, you gain a lot, and then you've got this DAG, which also completely optimizes the way your workload are processed. A good example is, let's say you've got a data set coming in, you add a column to your data set, and then for some reason you want to delete the column for your data set because it was a temporary column or whatever. If you do that in a relational database, the column will be physically in place, and that's going to be a very heavy operation. In Spark, it's never going to be created, and the optimizer can actually do that. And it's interesting. And when you looked at this chapter about laziness, I've timed a bit the different operation, and it's actually almost funny to see how Spark is doing this thing. So I really think in that I've got a strong feeling about making a parallel between teenagers and Spark. So.
And in terms of the architectural design of the applications that developers are creating and the ways that data engineers are leveraging Spark, what are some of the edge cases and quirks of the framework that they should be considering as they begin to scale their deployments? Again, in terms of the number of nodes and in terms of the volumes and varieties of data that they're processing.
I can't think of critical cases. Spark can ingest a lot of different types of data. So you don't have to kind of pre-process the data before you ingest them. Natively it handles text, CSV, JSON. With plugins, you can embark XML, and if you want to, you can also create your own plugin. Of course, all relational databases are easily integrated as well. So this part is pretty straightforward. The next part is all this data transformation, whether you're starting by doing data quality or directly doing some kind of heavy transformation on your data. This is usually being done by, you can actually combine SQL with the data frame API and using the machine learning API as well in this part of transformation. And that's also pretty straightforward, and I don't see any kind of specific cases where you need to be really aware of that. And once more, it's because at the end it's going through Catalyst to optimize your workload. So it gives you a little bit of a tolerance on what you're doing. It's not like when you've got to implement a map reduce algorithm where you've got to be very careful about what you're doing as a mapping and a reduce thing. Spark gives you a little bit more freedom there. And finally, when you want to share your data, or whether it's going to be in a file or it's going to be in a database, it's the same thing. One thing to consider is if you're saving in a database, for example, each task will try to have a communication with the database. So if you're on, let's say, 20,000 nodes and you've got, let's say something like, 5 tasks per node or 20 tasks per node, and they all try to communicate with your relational database, that just might be a bit tricky because I will do that at exactly roughly the same time. So you can actually bring back, you can repartition the data, coalesce the data, and then save it to your database. That would be probably an edge case where you've got to be careful about that.
And in terms of optimizing some of the processing, I know that Spark has support for user-defined functions. So I'm wondering if you can talk through some of the ways that can be beneficial and the approach to designing and deploying some of those user-defined functions to the Spark cluster.
Yeah. So just as a side note, before we go to the UDF, and you can edit that if the way you want. But I think a component which is interesting to understand about Spark is tungsten. So Spark does not rely on Java storage when it comes to object. Okay, let's say you're getting int or integers and strings as part of your data. Spark is going to first convert that, to serialize it and store it in a specific storage manager called Tungsten, which can actually compress the data. So this is also something where your data will be optimized on your behalf. And the ratio I kind of got from the engineering teams on Spark is that you win about 20% of the data. And that was back in Spark 2.0, so they probably did some progress on top of that. So basically, that's good to know, because when you've got, let's say you've got to ingest a gig of data, well, then you know that it's going to take only 800 meg of memory as well on your cluster. So that's one side note that it could be also interesting to the listeners. And what was your question?
And that's definitely very useful to know, particularly when you're doing capacity planning in terms of the node types and number of nodes when you're figuring out how much data you're going to be processing. So definitely valuable for resource allocation. But I was also curious about the use cases and design and deployment patterns around user-defined functions and some of the benefits that they can provide in terms of efficiency and ease of use when deploying an application on Spark.
Yeah, sure. So I actually, this is also something I really like, and I kind of liked it, and I'm making another plug for my favorite RDBMS, Informix. Informix brought user-defined functions in Java back in the 90s. But really, what's interesting as well is when you're using Spark, you've got a lot of built-in functions, okay, like splitting a value in or a column or cell into 2 or 3 or whatever based on a regex or whatever. That's the kind of functions that Spark will provide. And nobody should be surprised about that, or date conversion, date from a string to a real date. And so this is almost SQL functions you find everywhere. And of course, the thing is, that's the libraries that the community is providing as part of the package. So Spark offers this user-defined functions, UDF, where you can just build your own. So I like this concept a lot because it extends the richness of the product. And it also, one of the reasons I like it really a lot is you can leverage your existing libraries and your existing code. So in the use case of, for example, of having data quality, okay, and you're ingesting data in your system, and you already did all this data quality libraries that exist, and you know that they're reliable, and so you can just do a little bit of the plumbing and using the UDF as a plumbing mechanism between Spark and your existing library, and you leverage your assets like crazy in a matter of very short time. So this is something that Spark is also very good for. Deploying those are not that difficult because they end up being jars, and jars are just deployed. One constraint is that a lot of the libraries on the code you're going to add to Spark needs to be serialized when you're doing it in Java or Scala. But that's not that big of a constraint, I think. It was not for me, at least, on my teams.
And another area that I'd be interested in hearing about is any experience that you have in terms of writing tests and fitness functions around the applications that are being deployed to Spark so that you can do some of those quality checks that you mentioned and doing some validation of the various stages of the processing pipeline.
So, yeah, that's a good one. And I must admit that I don't have a good answer. So when you're using UDF and you're embarking your UDF, you can do it easily by testing outside of that. I don't know if I was fortunate or not, but we relied on external testing when we built pipelines with Spark. So it was not, we did not test each step within Spark. But there's a good framework for testing Spark, which is sponsored by IBM, and it's interesting because it can be automated to change some values automatically. So you can say, oh, I want to allocate that much memory to my execution, to my driver, to my master, and varies. And that's just a few of the parameters. And the tool will actually monitor and change that and give you a feedback of the results there for performance testing. So there's a small ecosystem. Well, not small. There's a growing ecosystem really about this kind of tools. Unfortunately, I did not have the chance to use that as much as I would have to.
And in terms of the actual deployment of the cluster itself, what are the necessary system requirements and any supporting technologies that should be considered for getting a Spark application up and running and getting the cluster deployed in a reliable and highly available fashion?
So there's a lot of different ways of doing it, and we could probably spend a few hours on it. The first thing is that Spark allows you to build your own cluster with only the Spark components, which means you're not required to use anything else. So my first cluster I built was a bunch of Ubuntu machines. You just start on one Spark as a master. On the same machine, you can start a slave, and on the other machine, you just start slaves, and you just point them to the master. And that's your cluster. Your cluster is ready. It's very fast in that way of deploying cluster and adding nodes as well. And the resource manager is basically provided by Spark directly. Is that enough for production? Yes, it's been enough for some project in production. Now, because your cluster or your physical cluster might be used by not only Spark, you will find other resource managers that work with Spark. So if you're coming from the Hadoop world, you will be able to use Yarn directly with Spark. And that's what, for example, Amazon is doing with AWS EMR, or you can use Mesos and DCOS. And we had a lot of fun doing it. And when saying a lot of fun, it's positive fun. It's not nightmare fun. And allocating more resources and distributing tasks was really nice. And more recently with Spark 2.3, Kubernetes is also completely supported. So if you're a Kube fan, you can use Spark as well. So really, you're building your cluster is fairly, I'm not saying it's fairly simple, but it's fairly flexible. And, you're not stuck to one resource manager. You're not stuck to one technology. You're really open to a lot of different things. And there's other project I've seen with other resource manager, but I've not had some, more obscure things or more targeted systems. But yeah, really comes standalone. Standalone mode in the cluster. You can have a Yarn. You can have Mesos. You can have Kubernetes. So that gives you a pretty nice choice already.
And with all these capabilities, it can be easy to start thinking that Spark is the right answer for every situation where you might need to do something with data. But what are some of the cases where you think that Spark is the wrong choice and some of the limitations that are imposed by the Spark programming model?
So it's not a transactional system. Okay, so you're not going to do you're not going to plug your cash register in your Walmart directly to Spark. It's still an analytics system. So all your transactional model will still rely on on another system. So that's one point. The other point is your data within Spark relies on memory. So with all the nice things about it and potential danger of having it in memory, like if it's gone, it's gone. Of course, there's reliability built in, okay, but it's not safe. It's not safe to disk, and it's not designed to save it to disk in the middle of the process. So this is something when you design your application that you may think about. And the data in Spark itself is immutable. So So that was a weird one for me to understand when I started working with Spark. Is really, what, you're doing this analytics system and the data inside is immutable, so it means that it doesn't change. What's the point of that? And actually, it comes to the kind of the low level almost architecture of Spark, where if you want to distribute your data, if you distribute your data and the changes in your data like a cluster of databases, you have this network latency, you've got this network issues that you can have all these things that your data can be out of sync. But if your data, you know that your data is not changing, you can only share the recipe or the DAG between your different nodes. And that's one great thing. Okay. So, but because it's immutable, then you're not going to do, like, for example, you're taking your relational database and you're going to update fields. Okay. That's not how you're going to do it. You're going to apply transformation and you're going to get a new data set, which is optimized, which is not going to be the copy of your old data, et cetera, et cetera. But it's not a directly an update like you would do in MySQL, for example.
And in terms of the book that you're writing, it's currently still in progress. And you mentioned that you approached Manning with the idea of writing it because you were so interested and excited by the capabilities of Spark and the ways that it's used. So, wondering if you can talk a bit more about your motivation for writing it and the target audience that you're trying to serve with it.
So when I started learning about Spark, it was in the idea of even if it was not directly said of data scientists, which I have a lot of respect for. I think they're really smart people, but I didn't feel like I was really completely being connected to their needs as a data engineer or data architect. So I started to look at resources, and it brought me to a lot of the examples, and I love to learn by examples. And most of the things were written in Scala. Oh, that's adding a burden, It's like, you really want to use your tool, but before you can use my tool, you've got to learn this new language. And that didn't please me that much. So I really said, okay, well, I've got to see how much you can leverage. And that was back in the early version of Spark as well. And later in projects, I was confronted to that. I get teams of engineers really efficient in Java who don't need to learn anything in Java except the data frame API from Spark. So I said, well, if we want to develop things around Spark, are we going to train all those nice bunch of engineers into Scala, or are we just going to leverage Java they know and try to focus their efforts on just learning the essentials about Spark and trying to understand big data through Spark? So that was the main motivation for my book. I found it damaging for companies I've been consulting with or working for, that they started doing some project in Scala, trained people in Scala. As soon as the people were trained in Scala, they found another job, and then you've got codes you've got to maintain in Scala, and you don't have anyone else, and you just take a little bit more efforts. Yeah, but at first your productivity might be a little lower, but you don't go through the phase of training your whole team to Scala, and that might be also a big debate we could start, and I don't want to start any troll wars or anything, but I think that Java is more readable than that's Scala. I think the maintenance is easier. You've got more tools. So I said that's when I went to see Manning. I said, this is what I believe in, and I would love to write a book about it. And basically, they said, "Bunko, let's do it." So that's what happened about a year ago.
And what have been some of the most interesting or useful lessons that you've learned in the process of writing the book, and anything new that you've learned in terms of the capabilities of Spark that you might not otherwise have been exposed to?
There's two folds to your question. First, writing a book. It's my first published book. I self-published a few times. I started self-publishing back in the early 90s when I was in college, and a friend of mine, we decided to write because we wanted to help our friends. We decided to write a book on C and C++ and the transition from C to C++. So that was a lot of fun, like almost 30 years ago. And it was fun because I was, a college grad, and it was a summer project. Then fast forward to writing a book with Manning, and my God, it's difficult. It's really difficult. I've got a great editor, Marina, but I've also written a lot of articles before, or tutorials for IBM Developer Works, for example. And you've got your editor that is actually just babysitting you. And then you go work with Manning, who are really great professionals, really demanding, and it's a lot of work. And it's really forcing you to be a better self. It's a bit like when you write a blog or when you write something for a magazine, and you've got an editor behind you, after you. It's like writing in middle school, right? Writing for Manning is the same thing as directly jumping into college after middle school. I love it. It's awesome. It's hard. So that's one thing. And I think I've made a lot of progress personally in the way about explaining things, in about the way of doing graphs and illustration. And there's a lot of illustration in the book, trying to find also the right examples, using real examples. Most of the examples in the book are based on real data sets, it's not big data sets, because I don't want people to download something like a few terabytes of data to play with it, but it's real data sets, so it has a real meaning to it. It's not, it's not like a funky data sets with just integers and things like that. So that was for the book part. For the Spark part is, I love the research. I love the research you've got to do, because I just finished chapter 10 on streaming, and streaming is not a very complicated paradigm, I think. But if you want to explain it, you've got to find this kind of useful little tips and useful entries for the reader to get your reader involved. So, for example, on this specific about streaming, a lot of the streaming people are thinking about network, and I didn't want to do network streaming to explain streaming, because I didn't want people to deal with netcat or to deal with ports on the machine and all these things. So I said, let's do directory streaming. So basically you drop files in a directory. And for doing that, I built a small record generator, because I wanted that the reader could run the examples, but just focus on the examples. So there's all this small ecosystem around the examples that I worked for, and I worked to provide the tools that the student can actually really focus and really learn on the key elements of the technologies and the chapter is going to work. So when you combine this two, I think this is really both a terrible and terrific learning experience for both the writer and the reader. So then you've got to pick if it's a terrible experience for the reader and a terrific experience for the writer, or the opposite.
And what advice do you have for anyone who is considering or currently using Spark? And what are some of the areas of interest that you're looking forward to as you continue on your journey of working with Spark?
So I love the idea of machine learning without the math. And that's one of the chapter in the book, which I think it's chapter 18 or something. So it's still down the road, but this is the chapter I'm kind of really looking forward at writing. When I started doing machine learning, a lot of the education is a very formal, college-like training on that. So first, you've got to understand the math before you're actually using the machine learning algorithm. And I think that's a wrong approach to it. I think especially when if you're talking to data scientists, that's fine, because that's the way they deal with it after. They look at the math. But and don't get me wrong, I love math. It was one of my favorite subjects. But I think that when you're dealing with engineers, as they like math, most engineers like math, but they don't have to understand why a logistic regression or a linear regression works. They just need to understand what's the best use case that is going that is going to be applied to that. And this is really, I would say, my next challenge and my next challenge for the book as well. And it could be 10 books on the same topic, but it's going to be only one chapter in this book at least. But this is something I would definitely love to see more, like, associating the use case you're trying to solve with the right algorithm, and not trying to learn first how the algorithm is working before you can actually use it.
And are there any other aspects of the Spark project or the book that you're writing or your experiences with either of those that you would like to discuss further before we close out the show?
There's always, Spark has been there for a few years now, and right now we're in version 2 of Spark, 2.4, that was released a few weeks ago, and Spark is also going through this different level of maturity. And one of the great things is that they are not afraid of growing. And so when you're looking at learning Spark, one thing that you need to be very careful about is which version of Spark are you going to cover. And so I'm not trying to say that because of my book, but just because of potential, just readers and users. Spark started by storing data in RDDs, which are still there, which are the basis for the data frame. But if you get a book or a tutorial on Spark and it's about Spark 1, you will find the RDD. And the very early books which have Spark 2 in the title are actually, they were too close to Spark 2 to actually embrace, to Spark 1, to embrace the full potential of the RDDs, of the data frame versus the RDDs. And it's the same thing with streaming. The first version of Spark included Spark streaming based on what they call discretized streams, and now which were kind of tightly linked to this RDD, this resilient distributed data set. So the same thing is happening to streaming now, which is structured streaming, which is based on the data frame as well. So you've got the same API and the same evolution of the product. So you need to be, so if you embark on a project, or if you start a new project, you've got to be a bit careful about what you're going to pick there. But even the API is not fundamentally different. It's about a bit of the different concept there. But that's basically how I would see things now. I'm kind of looking forward of the future of Spark, and it's growing, and user base and the tooling, the more and more of the tools you see around Spark, which are also very interesting, and the variety of the use cases, which are also pretty incredible. There's a bright future for Spark, definitely.
Yeah, and I suppose that's also worth mentioning that this is the second edition of Spark in Action, so I'm assuming that some of the differences people can expect between the first version and the version that you're working on now is some of the new capabilities that have been introduced with subsequent versions of the Spark framework.
As I said, the first edition of I didn't participate in the first edition of Spark in Action. It was mainly targeted for in Scala and Python, whereas my edition is more toward Java, as I said. And I think that they're a good complement to one another. To the concept I explained a little bit differently. I'm not saying mine is better or theirs is better. I think it's interesting to be able to have that, and so to have both perspective on it. But definitely the Spark in Action, the first edition, is covering more of Spark 1, and I'm exclusively covering Spark 2. Of course, with the links to explain the concept as they were in Spark 1, or to make sure that the reader is actually understanding where it's coming from, if it's got some kind of background there. I don't like to assume that you've got to learn different technologies to go to that point. I think that it's like, I don't want you to learn Hadoop to learn Spark. I don't want you to learn Scala to learn Spark. If you want to do that, you're going to be probably understanding a lot more things, okay? If you want to debug Spark, because it happens, learning Scala is useful, but it might not be what you're going to do anyway. So there's potential as well to grow, to keep learning, if you want to go there.
All right. Well, for anybody who wants to follow the work that you're up to or get in touch with you, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I still think we're suffering too much in data quality and data governance. It's so difficult. It doesn't seem to be easily quantifiable to demonstrate the importance of data quality and data governance. And that's really something I would like the data management part to make some progress there. And really data governance more than anything else. I think we are getting so poor at tracking those artifacts. Yeah, it's easy to get the metadata from a relational database, but then your data lineage gets lost somewhere. Now we are dealing with more and more AI models or machine learning models, and what is your life cycle of those models? Are you able to track down your hyperparameters? And I think that's really where this next generation of data governance needs to go and needs to embrace this thing, but in a more intrusive, in a more stealth way that it's being doing right now. I hope that that's something that someone will tackle.
All right. Well, thank you very much for taking the time to talk today about your experiences with Spark and writing the book. And for the people listening, there's going to be a discount code in the show notes for 40% off of any of the Manning books, including Spark in Action 2nd edition. And also check in the show notes for some details about a giveaway for a few copies of Jean's book. So thank you again, Jean, for all of your efforts there. And I hope you enjoy the rest of your evening.
Well, thank you. Thank you, Tobias. And let's talk soon. Bye.